Figure 3 shows a spinning flywheel, so this thing's just spinning around here. State how energy is stored in a spinning flywheel. Well, if it's spinning, if it's moving, it must be kinetic energy. State one way to increase the amount of energy stored in the flywheel. Well, if you want to increase more energy or have more energy in its kinetic store, you need to move it faster. So increase the speed, or you can increase the mass. And that's because kinetic energy equals half times mass times velocity squared. So if you increase mass or velocity, you're going to increase velocity speed, increase kinetic energy. Figure 4 shows a skier going downhill. She descends through a vertical height of 200 meters. The skier's mass is 65 kilograms. Calculate the change in gravitational potential energy. Use the equation here. That little triangle here, which you can see here, that just means change, so don't let it throw you. And you can almost ignore it's there. So gravitational potential energy is mass times gravity times height. Again, change in height because they're falling down or they're moving between two distant vertical distances. But again, just ignore it. You don't need to worry about those triangles. So we have height here. We have mass here. And we know that gravitational field strength is 10. So we just multiply those values together, 10 times 65 times 200, and you get 130,000 joules. And that would give you the gravitational potential energy. Now, calculate her kinetic energy at the bottom of the slope using the equation half times mass times velocity squared. This may look scary, but it's really, really easy. Just remember to write it like this, to actually write down half as being 0.5 times by the value for mass, which was 65, times by the value for velocity squared. So you just write velocity and then you multiply it by velocity again. So 36 times 36, and that will give you the answer. So 0.5 times 65 times 36 will give you 42,120 joules. Remember, I'm just using the data given to you at the start of the question. 65 goes here, that was the mass, and 36 is given to you in this question. So at the bottom of the slope, her speed was 36 meters per second. Describe how her speed at the bottom of the slope could be determined. So that's actually quite easy. What you're trying to do is imagine they're skating down and then you want to work out the speed along this bit. So you have to measure, remember speed is distance divided by time, so you'd mark two areas and time their distance between that two areas, presumably one right at the base of the slope and then another flag or marker a bit later on, and you divide the distance by the time. So measure the distance at the bottom between 2 points. Start a timer at first point and stop at second point. Use speed equals distance divided by time.